Welcome to the Exterior Installation Strategies for Success in the Field and Staying on Budget. I want to thank Ox Engineered Products for sponsoring tonight's webinar. I'll say Ox produces a wide range of structural and insulating materials, including their IsoRed CI series of polyiso rigid insulation. And you can learn more about those products at oxengineeredproducts.com. Today, we actually have Lee Bybee from Ox. He's their Director of Architectural Services, and he'll be here after Randy's presentation to help us answer any questions. Thanks for joining us today, Lee.
Pleasure to be here.
Do you want to, since we're here a few minutes early, do you want to say anything about this type of products that you have available, since we got a couple extra minutes that relate to the residential insulation market?
Yeah, I'd be happy to. Appreciate your time. Excited to be here with you guys. As Rob said, we provide structural sheathing and rigid insulation products for residential and commercial applications. Probably the product of most interest currently is what we call our Ox IS product. It's called insulated sheathing. Basically, it's a 4-in-1 product. It has structural sheathing, continuous insulation, air and water barrier all built into one. And so it's a 4-in-1 type package and the most cost-effective way of getting continuous insulation into your build. And we've got a number of different thicknesses based on the R value that you're trying to achieve. We have a 1/2 inch R3, 1 inch R6, and a 1.7 inch R10. So number of different options for you, but that gives you your structural sheathing. You can eliminate your OSB and provide you with pretty much everything you need to be able to achieve the new energy requirements that are out there with the code.
Great, thank you. All right, again, as people are filing into the room here, I just want to remind everyone who's just joined us that you are here this evening for the Exterior Insulation Strategies for Success in the Field and Staying on Budget. Go ahead and introduce yourselves in the chat. Feel free to chat with the other attendees as well, and drop any questions you have throughout the presentation in the Q&A box, and we'll do our best to answer as many of them as possible after the presentation. I also want to remind everyone that if you go to findhomebuilding.com/webinars, that's where you will find any of our upcoming webinars, as well as all of our past webinars. We do record all of these presentations. And if you go to findhomebuilding.com/webinars after tonight's presentation, in a couple of days, we will have a recording of the presentation. And we will also do our best to add any links to resources that Randy and Lee mentioned throughout their talk tonight. Let's see, we've got some people here from all over. We've got Amber from Wisconsin. Got Jean from Alberta. We've definitely got some people coming from some colder parts of the North America here. We've got Simon from Cape Cod. All right, okay, just a couple more minutes, everyone, if you'll just bear with us. We opened up the webinar just a few minutes early because we have, well, it's actually a good thing because we do have quite a few people signed up, and it does take a few minutes for everyone to file into the room. Zoom doesn't just open the door and let everyone all in at once. Let's see here. Just another minute. Well, while I'm here, since we've got Randy just sitting there and I haven't introduced him yet, I'll introduce you again in a minute, Randy, once everyone gets here. But Randy is a longtime contributor to both Fine Home Building and Greedon Building Advisor. And Randy has been a builder for, what is it, about 2 decades now?
I've been in the construction industry since the mid-90s.
Okay, so
yeah,
a little bit longer than almost 3 decades. And when did you get your start with the energy efficiency angle of things?
Back in 2009, when we kind of saw the downturn in the economy, I I got a little nervous on the building side, and I took a class on energy auditing. And as soon as I finished the class, I happened to stop by our local rural electric co-op just to see if they had any need for an energy auditor. I was hired on the spot and been kind of learning as I go. I mean, you pick up a lot of things. You remember what you did back when you were building, or the stuff that maybe you saw really didn't understand what was happening. Kind of file that away, and as you move through the building science into things, all of a sudden things start to click. And then put the energy on top of it. Being able to help people that maybe have a high bill complaint or are uncomfortable in their houses. So it all kind of snowballed on me, and it's been keeping me busy for the last 10, 12 years.
That's great. And how much of your business right now is focused on what sort of services are you offering to people?
I do quite a few code compliant testing, mostly blower door. There isn't a big market in my community, in my area of the state, for HERS rating, or we don't have anybody really shooting for zero energy ready housing, or the net zero, the Energy Star. None of those programs are really, nobody's really shooting for them, and I wish they would. But so really all I'm doing is just the code required testing, and then of course the energy auditing for these for a couple of different power companies that have high bill complaints. I'm also a licensed electrician, which is how I entered the market, and that's really helpful when you're working with a rural electric company, try to troubleshoot some of the issues with some of these houses.
That's good. All right. Well, as I said, we started the webinar just a little bit early to let the large number of registrants file into the room here. We've got over 130 people joining us so far, and I'm sure once we hit 6 p.m. here, we'll have quite a few more. So I think we're just about 6 p.m. right now. So I'm going to go and sort of start my introduction over again here. Again, welcome everyone to today's Fine Home Building webinar on exterior insulation strategies for success in the field and staying on budget. We're just getting started here. Please go ahead and introduce yourself in the chat, and throughout the entire presentation, please drop any questions you have in the Q&A box, and we'll do our best to answer as many of them as possible at the end of Randy's presentation. As I mentioned just a moment ago, I want to thank Ox Engineered Products for sponsoring this webinar. Ox produces a wide range of combined structural and insulation materials, as well as rigid polyiso insulation, which is, I think, probably the most appropriate product that relates to tonight's topic of continuous insulation. And you can go to oxengineeredproducts.com to learn more about all of the things that they provide for exterior insulation and structural needs. Again, I'd want to introduce Lee Bybee, their Director of Architectural Services. He will be here to answer questions after Randy's presentation this evening. And thanks for joining us, Lee.
Pleasure to be here. Thanks for having me.
Okay, and for the main presentation today, we've invited builder, energy design consultant, and good friend of Fine Home Building and Green Building Advisor, Randy Williams. Thanks for being here, Randy.
Oh, thanks for inviting me. This will be fun.
Well, I don't want to take up any more of your time because I know you have a lot to talk about. Lee and I are going to leave you to your presentation, and we'll join you in just a little bit for the Q&A session.
Okay, we'll see if I can remember how to share my screen. Is it up?
Yep, there you go.
Okay, all right. Well, thank you. So we're going to talk a little bit about continuous exterior insulation. So I live by choice in a very cold climate. I call it almost Canada. I'm about 100 miles south of the Canadian border. I'm in northern Minnesota. Not uncommon for me to see temperatures, minus 30 below during the winter months. I have seen them colder. It can get pretty uncomfortable in the area at times. And it's a known fact that continuous exterior insulation can increase comfort, decrease energy costs. And you would think, living in a very cold climate in the area that I do in Minnesota, we would be using it a lot. But the reality is we really don't use it hardly at all. It was first introduced into the residential code back, I believe, in 2012 for the nation, and Minnesota adopted that code in 2012, but they chose to eliminate the requirement of the continuous insulation, more because we use a lot of polyethylene sheeting, or the polyethylene vapor retarder or barrier on the interior of the warm and winter side of the wall assemblies. Exterior insulation it can become a double-edged sword, depending on the product that you're using. If you do have polyethylene sheeting on the interior, you can really limit the amount of drying potential for a wall assembly. And that's the main reason why the state of Minnesota opted to not include that with the code. In the projects that I'm involved with, I try to include it. I think it's a great idea. The benefits are all there, but it needs to be done right. To get started, I think I want to cover some of the code requirements for exterior insulation. But first we'll start with, of course, the benefits. The energy reduction. That's the main reason why people want to do it. They want to be able to save some costs or be comfortable in their homes. But there's other reasons as well. Sound is a big factor in a lot of homes. You're on a busy street, or you got an airport close by. Adding this exterior insulation can actually help with quieting the house a little bit. I have a few projects that we've done using exterior insulation, and the homeowners have, one of the things that they've said is how quiet the house has become. It's much different than what they were either in before or that they've experienced at all. So that's one nice thing. Let's see. Thermal bridging. Reducing thermal bridging is another thing. That's more on the energy side. The thermal imaging photo on the slide is one that I took a few years ago. Pretty common in my area to see all the framing members, especially when you get a good delta T or difference between the inside and outside temperatures. Durability is also a big one. Whoops, sorry. Let's go back a couple. Durability, anytime you're adding the exterior insulation, you're warming the sheathing, which if it's warmer, it no longer becomes a condensing surface, or hopefully it doesn't become a condensing surface. Keeping moisture out of our wall assemblies is a way to add durability to our structures. So let's get started with some of the code that goes along with the exterior insulation. Hopefully you guys have seen this before. Some of what we'll be discussing today will be climate related, climate specific, where you're located, either in the States or in Canada. Hopefully most of us have seen this map. This happens to be the most recent climate zone map for the US. I'm sorry for the people in Canada. I don't have a good version of the Canadian map with this kind of detail, but a lot of the decisions that are made when we're choosing building designs start with location. The decisions regarding continuous insulation are no different. Be aware that depending on the code cycle that of your area, the map of the code cycle may have some differences than the most recent. So there's another version of this that came out in 2012 where there's some differences between the 2021 code and the 2010 version of this map. You might want to make sure that whichever code cycle you're on, you're using the right map. I know in Minnesota, you can see the very southeast corner of the state has got climate zone 5. That green area is climate zone 5. We didn't have that before the 2021 code. We were all climate zone 6 and 7. Wisconsin had a lot of climate zone 7, and they don't have any left. So we're seeing some changes in the climate. And how you build, you really want to maybe adjust your building techniques based on some of these new climate zones that we're seeing. So here's where we start getting into the code. All the codes in this presentation are from the most recent version of the IRC, from the 2021 code. This table is found in Part 4, the Energy Conservation section of the IRC. This table shows a minimum insulation and fenestration requirements. It's a common table, or it's used in every code cycle. It hasn't changed a lot other than some of the stuff with the continuous insulation. So what we're looking at is the highlighted yellow area, the wood framed wall R values. And you can see climate zones 1 through 4. You can actually get by without having any, well, 1 through 3, excuse me. You can get by without using any exterior insulation. It's not required by code. You can use it if you want, but you're not required. Climate zone 4 through 8, if you're in Canada or in the northern part of Alaska, is where you're going to run into the requirement of exterior insulation as long as it's adopted by your local code. The first number, let's look at climate zone 6, for instance. That first number, 20, is the cavity insulation requirement. The +5 would be continuous insulation requirement. That's for a 2x6 wall. If you're building with a 2x4 wall, you're going to use R13 cavity and R10 of continuous insulation, or you have an option in this code cycle to not use any cavity insulation and just put R20 on the exterior. And again, this is on the 2021 code. If you're using something different, the 2018 or the 2015 or 2012 codes, there may be some differences based on this table.
Hey, Randy, just a
Yeah.
second.
Yep.
Can you go just check your display settings there? People are saying that they're seeing your notes on the side and not the full size slide there.
Okay, let me see if I can
Is it the display settings in the top there, maybe?
change. Yeah, I think
So
I got
look
to
at-
change my screen. Did that change it?
Yep, that's perfect.
Okay, all right.
Thank you.
Sorry about that. Okay. So there's another area in the code that starts talking about exterior insulation, and it has to do with the vapor retarder. I kind of hate to do this to you because the vapor is one of the toughest things in the code for people to understand. I'm going to quick read this, the code language. This is from R7027, which has the chapter 7 has to do with walls, wall coverings, basically. Vapor retarder material shall be classified in accordance with tables R70271. Vapor retarder shall be provided on the interior side of wall framings of the class indicated in the tables R70272, including compliance, and it goes through the other tables. I'm going to show you each of these tables just so you have an understanding of what the code's requiring. And the reason I'm doing this is, again, we start running into different code requirements based on the type of vapor barrier you're using on the interior of the wall. This next, whoops, sorry, touchy. Let's go back to this. The picture in this, that's what they call a smart vapor retarder. It's a vapor permeable product. That one happens to be Siga's Mirex product. It comes out of Switzerland, and it can vary its permeancy depending on moisture levels. So if you got a higher moisture level inside the wall cavity, it can actually allow some of that moisture to escape into the house or into the structure. That helps drying potential. It helps keeps our walls drier, which in turn adds some durability to the structure. Here we get into the that first table, that 70271 from the 2021 IRC, and this is what's required in all structures. You're either going to use a class 1, class 2, or class 3 vapor retarder. Class 1s are usually the polyethylenes, or they list the unperforated aluminum foil. Glass and metal are actually class 1 vapor retarders as well. Class 2 is defined as a perm rating of 0.1 to 1. And these are craft-based bats or these smart or variable perm rating materials, such as the Mirex that I had on the previous slide, and this membrane product that happens to be on this slide. This is CertainTeed's membrane. This is also a class 2 vapor retarder. Class 3 vapor retarders, you're getting to the 1 to 10 perm rating, and that's latex paint. You know, so how the wall will dry, you kind of want to think about that before you start throwing exterior insulation out. Or maybe you want to change the type of insulation you're going to use on the exterior based on what's existing in a wall. So if you're in my climate, for instance, where we're using a lot of polyethylene sheeting, you want to be careful not to choose an insulation product that has a very low perm rating or it does not dry well. You've kind of created you can at least have the possibility of creating a double vapor barrier or really limiting the drying potential of the wall cavity. So this next table, again, this is in the 702.7. This is the second table in this series. What this is listing is areas where, for instance, this class 1 vapor retarder or this, the poly, there's areas where we really don't want to use that at all. It's not permitted at all in climate zones 1 through 4. That you can't use poly at all on the interior of the wall assemblies. Moving into 4 through 8, you are allowed to use it. I don't recommend using a class 1 vapor retarder. Matter of fact, I don't recommend using a class 1 vapor retarder anywhere, with the exception of maybe the inside of a structure that has a very, very high moisture content. For instance, if you have an indoor swimming pool, or maybe a greenhouse that happens to be attached to the house, something like that, where you have a lot of moisture that's being generated inside the home. That's the only reason to use anything like that. And if you're getting into that kind of a design, chances are you're going to have somebody that's helping you with that design. It's not something that I would even design. That's tough. There's a lot of risk to those assemblies. Moving to the class 2, that's pretty much required in most areas. Again, climate zone 1 and 2, they don't let you use a class 2, with the exception of a few, the exceptions that are listed in the footnote A. Class 1 and 2 vapor retarders with vapor permeance greater than 1 perm when measured by the ASTM E96 water method shall be allowed on the interior side of any frame wall. It's got to be more than 1 on a perm rating before you're going to be able to use anything in climate zones 1 and 2. So most of the time you're going to use a class 2, and then hopefully you get the opportunity to use a class 3. Where you can use a class 3, those more vapor open or higher permeance products on the interior side of our wall assemblies, is when you start adding exterior insulation. You warm that sheathing, where if we get a little bit of vapor inside the wall cavity, it's not condensing. It's not getting, in my climate, I see it frozen. If there's a high moisture content inside the wall assembly, if we were going to do a retrofit or remodel, I've run into houses where we've gone to remove that insulation. It's been frozen to the wall. There's that much ice that's built up on that condensing surface or the wall sheathing, and adding that exterior insulation helps that. And again, we can move to a class 3 or more durable wall assembly that can dry. All right, so now we're into the next table. This is where you can use class 3 vapor retarders, as I was talking about, when you have enough exterior insulation. So continuous insulation in climate zone 4, if you've got 2.5 over a 2x4 wall or 3.75 over a 2x6 wall, you can now use a class 3 vapor retarder in a marine zone 4. And the list goes down. In climate zone 7, my climate zone, we have to use R10 on exterior on a 2x4 wall, or R15 on a 2x6 wall, to achieve a warm enough sheathing to where we're not worried about condensation on the interior side of our wall assemblies. So here's a question. why do we need more exterior insulation when we're using more cavity insulation? So for instance, my climate zone 2x4 wall, like I said, we might be using an R13 on a 2x4 wall, but we only need R10 on the exterior insulation. But when we move up to a 2x6 wall, that's maybe insulated R20 or R21, now we need R15 exterior insulation. So now we've got an R35 or R36 wall assembly with a 2x6. Why do we need that? It has to do with ratios in heat transfer or heat flow through a wall assembly. So when you add more cavity insulation, you're cooling down, or less heat is getting through the wall to that, our sheeting, to keep it warm enough from becoming a condensing surface. So it's all about ratios. This is the last table in this the section of the wall. This is where we can use class 2 vapor retarders. It's just a little bit lower. This is new to the 2021 code. We can use a little bit less insulation on the exterior as long as we're using a class 2 vapor retarder, which is either we can use a craft-based insulation, or we can use one of those variable perm or smart vapor retarders. Those are both class 2 vapor retarders. As long as we're hitting these insulation levels, we don't need with that smart vapor or the higher perm rating, we don't need to have quite as much insulation on the exterior. So we talked a little bit about the ratios earlier. This is actually, I believe this came from Building Science Corporation. They did the testing to figure out where wall assemblies are safe. How much exterior insulation compared to interior insulation do we need to make sure that we don't have a condensation issue at our sheeting point? Again, climate zone 7, our ratio is 43%. So 43% exterior to the 47% interior is our ratio. Excuse me, 57%. If you're in climate zone 4, you only need 16% exterior. If you get all the way to climate zone 8, for you guys up in Canada, you're 50-50 pretty much. So pay attention to the ratios. If you achieve these ratios, you shouldn't have any worries on any of the wall assemblies, with the exception of possibly if you have a building with a very high moisture content for some reason. Again, that indoor swimming pool, things may need to be changed a little bit at that point. But for the normal typical house, if you achieve these, you're good. Now, the problem is we've got these recommended R values, 50% exterior insulation in climate zone 8, exterior to interior. That's not what the code says, right? The code says, if we go back to this first slide, back at the energy code, right here, climate zone 7 and 8, for instance, we only need to have R5 on the exterior with R20 cavity insulation. But per the limiting the condensing surface, that's saying something different. The code doesn't jive completely at these points. If you're going to meet code, you should be fine just installing, the R20 plus 5 on a 2x6 wall in climate zone 7 or 8. But if you really want to move to a different interior vapor retarder, move to that class 3 where you just got painted drywall, eliminate the class 1 or class 2 where you've got another product that's inboard of the drywall. Then you've got to increase your insulation levels on the exterior to make sure you have a safe assembly. A little bit confusing. Just be aware. That's why I kind of went through this code section, just so you understood that there is a difference between what's safe and being able to move to a more vapor open or higher drying potential wall assembly than what the code says. Okay, so I've thoroughly confused everybody, I'm sure by now. We got any questions, Rob? Anything that's pressing that you want to
Yeah,
Bring
well,
up?
one comment, Robin mentioned sort of the concept of the dew point temperature at the sheathing, and that
Mhm.
might be just sort of good thing to mention as sort of how this stuff is figured, how you figure out what information.
Exactly. In my climate, it seems like it's always a frost at the at the sheathing level. It's not always just wet. In the middle of winter, we always see it frozen. So, but in other climates, of course, you get into climate zones 4, 5, 6. You may see just some moisture at the sheathing level. And you're right, that is the dew point temperature. And it is relative to indoor humidity levels and the temperature of the sheathing. That's why we added exterior insulation, just to try to warm that sheathing so that moisture isn't an issue.
Okay, and Noah was this was more of a statement, but I could see this being a question. Is does the insulation type matter with those ratios on the outside?
That is for the most part, no. Whether you're using a blown cellulose or a fiberglass or a mineral wool, those are, the fibrous are pretty much the same ratio. Where you might get into a little bit of a difference is if you're using a closed cell spray foam. You've got a vapor barrier that's built into that product as long as it's being applied at a great enough thickness. There might be a little bit of a difference there. Again, I haven't seen the testing results. I'm sure they're out there. I haven't seen them to know if it makes that big of a difference between the ratios. I'm not sure. Good question
Okay.
though.
Yeah, I mean, I know you cited Building Science Corporation as the source of one of those studies,
Yep.
and Building Science Corporation's website is actually I find one of the best places to find detailed information
Yes.
on stuff like that, and they have a
Yep.
very decent search engine on their website too. Another question was the vapor barriers on table 702.7, are they assuming continuous over face of the studs or traditional backings on the bats, or does it matter?
It really doesn't matter. You're talking about a craft based. We're not trying to solve for air with that. This is a vapor issue. And as long as it's for the most part continuous, it's not a problem. There can be some gaps and cracks. It's when you're trying to solve for air that you really want to make it continuous. And fiberglass, the craft base on that type of insulation does not make a good air barrier. So that's the other way that, and it's much greater potential for moisture to move into a wall cavity is by air movement. So if you have an air leak into a wall or into a ceiling or something like that, that's going to move way more moisture than anything that can be diffused through a building product like drywall or wood paneling or whatever the product happens to be.
Yeah, I mean that's a good point because it's easy, I think, for people to get confused between an air barrier and a vapor barrier,
Mhm.
and the air barriers have to be continuous without holes, where the vapor barriers need to be essentially covering the majority of the surface area.
Correct.
I don't want to. We've got a bunch of questions rolling in, but I want to let you get back to your presentation in just a minute. Someone asked about how the tables were citing 2x4 versus 2x6 walls for the ratios, but my understanding is it's really just about the R value ratio. The 2x4 versus 2x6 thing is more about how much insulation you can fit in that space, right?
Yeah, right. A 2x4 wall, for instance, you can still get R11 insulation. You can also get R15, or if you go to a closed cell spray foam, you might be R 18 or 19, something like that. So it's possible to get more insulation than that. If you do have that much, I would try to stick with the ratios as much as possible. If you're going to a rigid rock wool or a rock wool bat with an R15, pay attention to the ratio of your climate and try to match that with the exterior insulation. I think you're still limiting the flow of heat through that assembly. So pay attention to the ratios. Yeah.
Okay. I'm gonna ask one more question before you get back to your talk. But people were sort of following up on the question, does it matter about what the exterior insulation is? People were asking, what about a more vapor open exterior? insulation, like a
Yep.
mineral wool, does that matter with the interior vapor barriers?
Uh, it can make a difference. So for instance, in my climate, if I'm doing a retrofit and I know there's polyethylene sheeting on the interior side of a wall assembly, I'm going to look for something that's a little more vapor open to use as an exterior insulation. I want the best drying potential that I can have. I don't want to have issues down the road where I'm having to come back in and explain to a homeowner why they got water dripping out their siding, or that kind of a problem, or underneath their siding, out between the insulation and the sheathing, or wetness, drywall that's falling apart, or a damp floor in an area or something like that. So I'm going to try to keep it as open as I can as far as vapor goes. And if you don't know, you're better off trying to stay more open if possible. And we're going to get into a few of the insulations here in a minute. There's four of the more common ones that I'll hit. A couple of them have a little bit higher perm rating that allow better drying capacity to a wall assembly than a few of the other ones. So yeah.
Okay, great. So I'm gonna bookmark a bunch of the other questions that have been popping up for the end of the presentation, so you can get back into your present. But we'll do our best to answer as many of them as possible later.
Okay, sounds good. All right, so back to now we're into the common exterior insulation types. These are the first two. Extruded polystyrene is the first one. That's the picture on the left. That's usually the colorful insulation, the blues, pinks, yellows. I've seen them green. XPS is manufactured in a continuous extrusion process, forming a closed cell matrix sheet. XPS is an R value of approximately 5 per inch and water vapor permeance of approximately 1.5 per inch. This restricts but does not completely stop water movement. The insulation is available in different densities. I believe the higher the density, the more vapor closed or lower perm rating it has. Most of the insulations that we use in the construction trades are going to be a 15 or a 25 pound per square inch version. The picture on the the picture on the right shows expanded polystyrene, which is EPS. That's the white bead board. If you've ever worked with it, usually when you're done cutting it, it looks like it's snowed someplace. There's white beads all over the ground. This one's got a little bit lower R value, typically R 3.6 to 4.2. It's also got a little bit higher vapor perm rating. It's got a perm rating of 5, again, depending on density. There is an alternative to EPS called GPS. It's a graphite expanded polystyrene that has a little bit higher R value. You're up closer to 4.5 with that. Both XPS and EPS are manufactured using a polystyrene, which is a thermoplastic. Most versions of XPS use blowing agents in their manufacturing that can be harmful to the environment. Some of the newer ones I know that have come out are the XPS versions are using a better blowing agent. They've made some pretty good improvements to make them a little better for the environment. The next two, polyisocyanurate, or polyiso, shorten it up for that, and the other one is rigid mineral. Polyiso is a thermoset plastic. It's a polyurethane foam. Has the highest R value of all the common exterior insulations, up to R8 per inch. The insulation does lose some R value as it ages, but still typically remains higher than the other insulation options. The most common facer for polyiso used as exterior insulation is that foil face, like what is shown on the picture on the left. It does help retain the higher aged R value, that foil facing. But it can, and it can also be a radiant barrier in a wall assembly, assuming there's an airspace between the foil facer and the cladding. The foil facing does make the permeance of the product low, though. It's considered a class 1 vapor retarder. It's got a very low perm rating. The last one, the mineral wool is, mineral wool is that's made from basalt and steel slag. So it's rocks and a byproduct of the steel industry. They're whipped into a fiber. It has a a very high permeance or perm rating. That's 35, so it can move a lot of moisture through the product. Our values range from 3.8 to 4.3. They do increase, which is interesting, slightly as the outside temperature decreases. So they actually gain a little bit of R value in colder weather. One thing nice about exterior insulation, the mineral wool insulation, is gaining popularity in wildfire areas. Its resistance to damage at high temperatures, along with its natural flame resistance, is a benefit if you're in an area where you have wildfires that happen, California, some of the Rocky Mountain areas. There are a few other choices as well: expanded cork board, low density wood fiber, and a couple other foam products are available. I've seen closed cell spray foam used outboard of the sheathing. I've heard of using a loose fill fibrous insulation like cellulose outboard of the sheathing. But those processes or products are not common. The four that I listed are much more common in our building industry. Okay, so we're getting into the how do we fasten, or how do we install exterior insulation? You know, the first section is fastening. There's a few different ways to attach exterior insulation to a wall. How you choose to fasten will depend on a few factors. First, how thick is the insulation? You know, you can get quite a bit of insulation on an exterior wall. I know one guy in the Atlanta area that's, and I've got a picture, the last picture in this slide show is, shows one of his details. He's got 6 inches of exterior insulation in Atlanta. Pretty crazy. The orientation of the sheathing type may have an effect on how you fasten, what the cladding is. You know, are you adding a rain screen? What's the orientation of the cladding? Is it vertical or horizontal? All these will come into play as to how the exterior insulation is attached to a structure. Usually, what we do is we'll attach the siding temporarily, and then we put a rain screen up, a vented rain screen, much like the picture on the right. So we just need some kind of a fastener to hold it temporarily until we can get that rain screen up, because that rain screen is really going to hold onto the insulation. It can't go anywhere once that's up. The one that I use the most is that bigger washer. It's I don't know if you can see my screen, but it's pretty good size. It's probably a 2 or 2.5 inch round washer. You have to add the screw. We just put a couple in to hold a panel, and then we go on and again with the vented rain screen and install that. So how do you plan the bottom of your wall? You know, how are you going to start this stuff? You know, depending on what you've got, what you're working with, that's exactly what it's going to depend on. What do you have? So the picture on the left is one of my projects. We had an ICF stem wall, and I just arranged the framing so that the exterior insulation was flush with the outside of the ICF. We added a vented rain screen to the exterior, so the siding was actually out another 3/4 of an inch, and that worked out really well for that project. The photo on the right is another version. If you're in an area where maybe you're using this assembly where you're doing a retrofit, you've got a house that's existing. You're adding exterior insulation. You want to make sure that the rodents or bugs aren't climbing up and moving through your insulation product. This bent up perforated metal is one way to do that. You know, have it bent the size that you need it. You can place your insulation in it. You still get some drainage. You know, if anything should become wet back there, it can move out and hopefully dry. But that bug thing is something that you really want to think about. If you're in an area with termites, you really want to think about how you're detailing your insulation. You don't want to have those things running rampant through the insulation products. So next is, what do you do with the water resistant barrier? You know, do you put that outside the insulation? Do you put it on first and then install the insulation? Again, it works both ways in most instances. You know, I typically have my my WRB is on the wall sheething. You know, whether that be a fully integrated product like zip sheathing, or if it's a peel and stick WRB that I've put on first, and then I add my insulation to the outboard of that. The problem can be is, what about the planned openings, your windows and doors? How do you address that? There's ways to do it depending on where you want to install your windows. Do you want to install them at the sheathing, or do you want them all the way outside? Are you using a nail flange type window install where they're going to be moved all the way to the exterior of the exterior insulation? All that's going to come into factor. You know, you really got to think about how these assemblies are going to go together, and make sure you plan your details so that they address both water and air, especially water. You know, you don't want water getting into some of these areas around the windows or doors or other openings that you have to produce through this insulation. But there's a lot of choices. There's a lot of ways you can do this. There is one other insulation product that we didn't address yet, and that's it's called a nail base. And what that is it's an insulation that has a sheet product that's attached. So for instance, OSB, or Zips R is actually a nail base. The difference with that is a lot of times you're attaching that product directly to your framing. So you've got your 2x framing, then you've got this insulation layer, and then you've got a layer of your sheathing outboard of everything. And it's kind of opposite of what we're normally thinking of with continuous exterior insulation. Your sheathing is still outboard of the entire assembly. Whether you're a fan of that process or not, I mean, it seems to be working. There's a lot of people that are moving that direction. In my climate, I always worry about what the temperature is of that sheathing. You know, is there an issue? Probably not. I'm sure the Zip R probably works great, or the nail-based products. I know some other builders in the area that are using that nail base, which just happens to be an OSB bonded to a EPS foam in various thicknesses, and that seems to work okay. But it's still, there's a lot of planning that has to go to make sure that your openings are correct with that. Speaking of the openings, you know, the windows and doors. Again, if you're using a nail flange or the Audi window is how they call it, how are you attaching that? You know, if you've got, for instance, 6 inches of exterior insulation, you're not going to mount your window right to that insulation. It's not going to work. It's going to compress. A lot of people are using bucks, a window buck. The picture on the left is actually what's called a thermal buck. It's a thermally broken window buck. So that the inside of that is a foam product, and it's got a hard case on the exterior. It's hard enough to where it doesn't compress when you mount your window. It's a great option. A lot of people are still just using a 2x4 or 2x6, or ripping it down to the width that they need and building their own buck, and that works as well. You do have a little bit of a thermal bypass at that point. You know, you've got solid wood, but they're usually smaller areas. It's not as big of a deal as the rest of the house, where you're losing the rest of you're protecting the rest of the stud cavities from that thermal bridging. So there's different ways to do it, but you have to think through it. If you're mounting an indie window, you know, you're mounting your window to the center of your wall assembly. Now you've got a lot of water management details that you're going to have to think through. How are you going to accomplish that? Lots of ways to do it. There's lots of good sites online. You know, a lot of the manufacturers, both windows and insulation manufacturers, have details that they can help work through depending on how you want to mount your windows and doors and other penetrations. So how do you attach other things through exterior insulation? For instance, decks, or maybe you got a 3-season porch that you're with a roof that you're trying to figure out how to attach to your structure. You still want to maintain you know, the thermal benefits of the exterior insulation. Well, a deck, for instance, on the picture on the left is actually a product that somebody came up with. It's called the main deck bracket. It was actually this. I grabbed this picture from Fine Home Building. It was an article. I think Mike Gerton might have talked about it. It's a product that stands the deck off, allows you to insulate around it, and still maintain the integrity of the framing for the deck. It is aluminum, I believe, so it does have some pretty good thermal conductivity. It's going to get pretty cold. So you may have a little spot if you're looking through at your rim joist or wherever this deck bracket happens to be mounted with a thermal imaging camera in the middle of winter. You may be able to see where that location is. But for the most part, you're limiting the attachment. You've got that insulation between the deck framing and the actual insulation to maintain. Other products, there's the Simpson Strong Tie has several products out. The picture on the right is you actually just use a block to make sure you have a point in the deck that you aren't compressing the insulation. So it could be a 6x8 or 6x10 block. You mount your deck bracket through with those through bolts, attach it that way, and then the rest of the insulation is intact behind the deck ledger. Same process with if you're trying to tie a roof for a 3-season porch or any other attachment that you need that's framing. These are methods to eliminate your thermal bridge. Yeah, planning the electrical, mechanical, and plumbing systems. That can be a little bit tough when you're dealing with exterior insulation. When you're planning this, the first thing that you got to determine is who's going to be responsible for installing these systems. And when do they get installed? Are you drilling your ducts for your bath fans, for instance, before or after the installation's up? Obviously, hopefully your electrical wires are out, shoved out the wall. You can get your air barrier in place if you're using an air barrier against your sheathing, and then install your exterior insulation like the picture on the left, and add your electrical box that way. Plumbing are another problem. You got water lines that have to go outside. We always use frost-free. We got a 12-inch frost-free hydrant where the shut-off valve is actually 12 inches inside the house to keep them from freezing. That can be a little bit of a challenge, trying to find a location point where you can shove something that's 12 inches long into the inside the house and not have it exposed in somebody's bedroom or the kitchen or something like that. So, but then how do you insulate around those things? And again, back to who's responsible for it. Is it the contractor? Is it the guys that are installing? Is it the siding contractor? Is he going to take care of the details of making sure the insulation is right around these things and making sure things get sealed up before the siding goes on? It doesn't matter who does it. It's just somebody has to do it. Just make sure that you have a plan in place to discuss all these things with trades that have to work around the exterior insulation. Now we get to the claddings. Cladding. So you've done all the work to install your exterior insulation, and then the associated parts and pieces that you had to do to make sure that it was all right. Now the most disappointing part of the whole process is you got to cover all that work up. You're never going to get to see it again. So which cladding you choose and how it's installed will be dependent on a lot of factors again. How much of the exterior insulation did you add? If you've done R5 and you're using XPS insulation, for instance, you've got 1 inch of insulation and you're installing vinyl siding, you might be able to just nail right through everything and not have a problem. But what do you do if you've got a stone veneer, a heavy cladding type, and you've got 6 inches of exterior insulation someplace? How do you address that? Chances are, if you're going to get into the heavy claddings, you're going to have some engineering involvement to make sure that things are supported right. You're not going to drop anything off the side of the house where it could hurt somebody or create some damage. The other ways that they're attached a lot of times is with that vented rain screen. That what I do on most of our projects is with the 1x3 or 1x4 strapping that goes on. That becomes our cladding attachment point. And we can attach just about any of the normal claddings, even the fiber cement siding. that's still light enough where we're not going to have any worries about attaching into a 1x that has 6 inches of insulation behind it. Now, that being said, you want to make sure that you follow the recommendations of both the siding manufacturer and the insulation manufacturer on attachment points. One or the other, or maybe both, have recommendations of what they like to see of how to attach these cladding systems to the side of the building. One thing that we didn't touch on yet is the cladding that is both insulation and cladding, and that's EIFS, or oops, sorry, back up. I'm trying to remember what that acronym is. EIFS is the exterior insulation. I don't remember the rest of it.
Finishing systems, I think.
Exactly. Yep,
Yeah.
that's it. So it's a synthetic cladding that goes on top of usually it's an XPS. That's all I've ever seen is EPS, excuse me, EPS insulation. So it becomes both the cladding and the insulation product at the same time. You're dealing with stucco, which can be challenging. At times, you want to make sure your water management details are extremely well thought out. But there's been some pretty big lawsuits and problems with those. And I've seen a few of the EIFS problems where we get some moisture behind it, and it pops the cladding or creates a water issue inside the wall assembly. So if you see a lot of that commercial. In my climate, I have nobody's doing stucco. We just don't have the workforce or the talent to do that kind of a finishing system on residential projects. We see it on some commercial projects, but not residential. So there's going to be a lot more questions, I'm sure. I covered everything fairly quickly. This is a fairly brief presentation on exterior insulation. This is the picture of my buddy in Atlanta that used that 6 inches. That's rock wool or mineral wool, 6 inches of mineral wool insulation outboard the sheathing. Pretty impressive assembly. He did build, that was a metal framed structure, residential metal framed. And that's the reason he chose to do that, even though he's in Atlanta. Pretty neat assembly though. All right, Rob, what else you got? You got to have a bunch of questions now.
We definitely do. So let's see. Well, I just wanted to mention one comment. Roger, early on, after we were going on back and forth about air barriers versus vapor barriers, commented on, he said, a vapor barrier with gaps and holes is not a barrier. And what do you have to say about that?
In a way, he's right. But in my climate, I'm always my vapor. If I'm using a vapor barrier, vapor retarder as a air barrier, it's sealed. It's sealed on all sides. I have as very few gaps and penetrations through that as possible. But that being said, vapor itself isn't smart. It doesn't know where the hole is. It doesn't know where to look for the hole. So for instance, if you're using a vapor retarder sub slab underneath your slab, Joe Stiebrich makes a comment, heck, we can take our golf shoes and go walk all over that thing if we want and cover it up, and it's not going to be an issue. The vapor, you're going to get some, but you're going to stop the majority of it. Is that right? No, I'd be stopping as much as I can for me, but vapor moves much more in air, and that's where these little holes make the difference. Is the air is going to find the holes based on just the movement of the air through the hole, and that's where the vapor is going to travel and end up in places we don't want it. So if you listen to Stiebrich, it doesn't matter. You're still stopping the majority of the vapor. If it's got a few holes in it, again, I'm with you. I don't want any holes. I'm going to seal it up the best I can. So.
Okay, so I'm actually going to turn my camera back on if you want to turn your slideshow back
You
off,
got it.
and we can welcome Lee back, so in case he has anything to add in any of these questions. So I'm going to rattle off a few more questions here. Well, John asked early on, I guess, just on the concept of exterior insulation in general, what about just adding less framing or more space to your walls? I mean, what is the main reason to choose exterior insulation as opposed to just filling your walls with more insulation? You kind of touched on this, I guess, with the
Yeah.
dew points and the.
Exactly. Durability is probably one of the bigger ones. Stopping that thermal bridging is another. One thing when you're using exterior insulation, you gotta, when you figure your R values of your wall out, everybody talks about, hey, I got a 2x6 wall, it's R20. Yeah, that's R20 in the center of the cavity. When you start adding in the framing and everything that goes along with it, all your headers, all that, your actual R value of that opaque part of the wall isn't anywhere near 20. It's closer to 16 or 17, depending on how much framing is involved in building the home. But when you add exterior insulation, that no longer becomes a problem. It's whatever you add to the exterior is added to that final weighted R value. There's no reduction in that value. So.
Okay. Let's see. So, if you've got an exterior insulation, are we concerned about them getting wet during installation before cladding and siding goes on? And does it matter what type of insulation or cladding we're talking about?
Mm-hmm. Obviously, we want to keep everything as dry as possible. We don't want moisture ending up in wall assemblies or places where it takes a long time to dry. So if possible, you want to keep it dry, get it covered as fast as you can with your WRB, get a roof. Of course, you're not putting your insulation on, hopefully, until the roof is on. Hopefully you have overhangs, which will help keep things drier. That being said, I have seen some of the more vapor opener, the more fibrous insulations, like mineral wool, where they've been saturated and they dry out fairly quickly. We had an instance last year. I've got a project called the Barndominium, where it was a winter build, and we had a lot of snow and moisture inside the structure. Got as much of it out as we could. We still ended up with some in places we didn't want to or want it to be. And over the course of a week, once we got rid of the liquid water, everything dried out. We dropped our humidity levels inside the structure. The insulation dried out. It was able to drain. So there are some that drain pretty easily. I have also seen XPS insulation, the extruded polystyrene. It's not supposed to have a very big. It's not supposed to absorb much moisture at all. I've seen instances though where it's been buried, where a 4x8 sheet, one guy can't lift it. It is so heavy. It is so saturated. I can't explain why it does that. It's not supposed to do that. I don't know if it's got the wrong facer on it, if they're using the wrong product, the wrong application. I'm not sure, but I have seen that. And so keeping things dry, in that case, that insulation is going to take a long time to dry out. It's very, very slow to get that moisture back out of it. So don't dig up any insulation that's saturated and put it inside your house, I guess. Not a good idea.
Yeah. So now, and then maybe this is a question for Lee, and you kind of touched on that earlier about Randy, about going to the manufacturer for recommendations for fastening and details around penetrations and windows. Lee, is that something, like if someone were using one of your products, how would you recommend someone get the right details for that?
Yeah, no, I would definitely recommend talking to the manufacturer. We've got several details on how to do that with our product. Window manufacturers as well have some recommendations. It's just really kind of returning to the code and the requirements for really what you want to look at is warranties. There was a question on there saying, can I just install siding to the sheathing? And I get that quite a bit. But if you look at the code says the sheathing needs to be a minimum of 5/8 inches thick to be considered a nail base. And so usually your siding is not going to, or your sheathing is not going to be that thick. But then you can kind of go to zip. I think zip actually allows less than that, but it's just a matter of understanding what the manufacturers are requiring and the warranties based on those installation details.
Okay. I know someone asked, because you'd mentioned about nail base for siding, and you touched on this, Randy, about the furring strips sort of doing double duty as being rain screen um,
Cladding.
and a sturdy surface to attach
Mhm.
your cladding to. When people get into the thicker exterior continuous insulations, like what are our biggest challenges and what are our best methods for making sure we're attaching to something solid underneath the insulation?
Yeah, so you're going to be attaching into your framing. You know, you're not going to just try to screw into your sheathing. You got to have a minimum embedment of a fastener in the framing material, and that's usually listed by the manufacturer based on thickness. So if you're up in that 6 inch, you know, you got a lot of exterior insulation. They're probably going to spec not only the size and length of the screw, but that may be based on the type of cladding that you're putting on it as well. You know, if you're trying to attach a veneer stone to it, it might be a little bit different fastening schedule than if you're attaching a hardy siding or a true wood siding. That, you know, there's a little bit of weight difference there. So it all goes back to the manufacturer. Go back to their or third party engineering. If you've got an engineer involved, they may specify something a little bit different as well.
Okay. Any tips on finding or reaching that framing when you're starting to get into the thicker layers?
That's the trick, and it can be very difficult. You know, it's when you're trying to drive an 8-inch screw through all that material, there's a chance that you're going to miss. But you try to mark your framing out as best you can. You know, a lot of the installations are you can get it to accept a chalk line or a marker. Even the fibrous, the mineral, you can draw on that. It works. So locate where they're at, and then if possible, have somebody on the interior, especially if it's a new build, have somebody on the interior to kind of watch, make sure that you've hit. It doesn't take much to end up at a little bit of an angle and just miss the stud, or even be off by an inch. You know, it happens.
Okay. Now, Lee, one thing we talked a little bit about, but I think a couple of people are curious about is when you're dealing with exterior insulation, where does the water resistive barrier go in it, or does it not matter? Is there different strategies for putting it in a different place?
It depends on what insulation you're using. For example, I manufacture polyiso, so it basically performs as a weather barrier, and we have facers on there as well that are code approved as a weather barrier as well. And so all of what we do is going to be a weather barrier exterior from the insulation. But if you're going to get into open cell scenarios where you're using EPS or rock wool, then you're going to have to do a weather barrier behind the insulation. So it really comes down to which product that you're using and how that kind of plays out.
Okay. And I think whether or not you need one, like you were saying, that the polyiso can act as that weather barrier if you tape, if you tape the seams. I think that we had several people sort of asking about the affordability, the budget component, because we kind of we put that in the title of this presentation. And I'm kind of guessing that it comes down to, like, when you're choosing a material, sometimes it's you're eliminating certain steps by actually having that material or that assembly do dual purposes. I mean, can either of you sort of speak to when you're obviously when you're doing an exterior installation, especially if you're doing it with people who haven't done this type of assembly before, there's a learning curve, or you're dealing with tradespeople who are just not accustomed to the details. So what are some of the strategies or tips for actually doing exterior insulation affordably?
Lee, you got anything?
Yeah, I can touch on that. I mean, really, composite systems are going to be saving you a lot in material cost and also in your install labor and time. For example, Rob talked a little bit about, and Randy talked a little bit about the zip system. My system is quite similar to that, where you've got kind of a 4-in-1 system that gives you a little bit of an advantage on the cost saving side of things. And so if you can combine that all into one, that's going to give you substantial savings across the board in your project. So if you're looking for a continuous installation, I can almost guarantee you mine's going to be the most cost-effective way of achieving that is looking at a composite system like that.
So there's a few other things too to take into consideration is make sure that you're if you're doing these systems, make sure your HVAC guy knows. You're adding an R value. A lot of times the HVAC companies will be assuming that it's a code built wall, whatever the minimum is. And if you're going beyond that, you're making it better. You're making the heating load for the house that much less as well. Maybe you can downsize your air conditioning, your heating equipment. That'll help offset some of the cost. As far as making sure that your labor force, your workforce understands how to do it. I know a lot of the installation manufacturers. Now, I can't say all of them, but I'm hoping that a lot of them offer. They've got salesmen that are spread out across the country, and they want to make sure that you're successful with using their product. So a lot of times they'll send a guy out for a couple hours or maybe a day to help you install, or at least get you started, make sure that the process is going right, that you understand how all this goes together. And if that's available, make sure you use that, especially in your first time trying to install this. It sounds like it'd be really, really simple for the most part, just nail the stuff on and go. But there's a lot of tricks and tips that these guys that have done a lot of this have learned over the course of their careers and use them. They got a lot of knowledge that'll help you out, hopefully save time and money.
Thanks. There were a couple of questions about retrofit. What do we have to worry about as far as like as far as flashing details, window and door details, that sort of thing?
They can be challenging. Anytime that I would be involved with a retrofit, adding exterior insulation, I want to know what's there. Making sure that you're designing a system that I'm not going to create more problems for the homeowner down the road or make things worse. So that's the first step, is to make sure that you understand what's behind there. If anything, even in some of the older homes, there might not be any insulation, and you've got a lot less risk in those cases. But if you've got a wall full of polyethylene sheething on the interior, that's an issue. The other thing with retrofits, I guess, I don't know, Lee, do you have anything? I can't think of.
No, go ahead.
I was just going to say, I guess the big question I think for a lot of people is people are hoping that they can cut corners because they don't want to pull their windows out, and they want to, you're putting a heavier load on the flashing and all the other things on there. So it's
there's ways to do that.
Someone mentioned
it all comes down to the details, though. Making sure that you're executing whatever system you're going to use for the flashing, make sure it's done well. If you're leaving the windows, one thing with windows that are nailed against the sheathing that I'm always looking at is, if we choose to do that, what happens if that nail flange, if we have to remove that window down the road? If we've packed the insulation around that window, now do we have to disassemble a wall to get the window out? So if you're installing leaving an existing window and happens to have a nail flange or whatever, if you can make sure that remains accessible to be able to service at some point down the road, do that. But then you still have to figure out, how are we going to make that watertight, with the flashings. And sometimes it's creativity. It's not cut in stone.
Yeah, I almost wonder, because I know I've people have said, you've got to pull your windows so you can flash them properly. But with a lot of the tapes and liquid applied membranes now, the details almost seem like you're doing the same thing with with a new window that you would hopefully be able to do, to tie things into your existing windows and get away with flashing it with those products.
It's possible. It's all, it is so, it depends, it's true of so much of the building industry, is that there's so many it depends that it's hard to answer that directly.
Yep.
But there are methods, there are ways to do it.
All right. Now, circling back to a comment that you made about, reaching out to potential people from the manufacturers to come and help you out. Like Lee, what would be, if we were going to use one of your continuous installation products, like what would be the first, what would be the best way to contact or ask for help with those details? Is there a number they should call, or is there, are there, is it more about customer support people or?
Yeah, it really just kind of comes down to that. So I've got, I run a group of sales reps across the country. I probably have 60 different reps around the country that work with whomever might call in. And I run the architectural services for the company. I'm an architect as well. And so I'm happy to connect with anyone if you've got questions or, details that you can send over and kind of walk you through any of that information. Happy to assist. I left my information on the little sidebar here. I don't know, Robert, are we going to send out contact information as well?
So there'll be some follow-up emails going out to attendees, but also, like I mentioned earlier, if people go to findhumbling.com/webinars after this presentation, check back in a couple of days and we will add the video recording of the presentation, but we can also add any information either of you want that you think could be helpful to the people who are interested in the topic, including where they should go on the website for contact and for help or contact information, or even if you wanted to have direct contact information for whoever they should reach out to for help. So if you guys, after the webinar, if you guys both want to email me anything you want me to add to that webpage, I will go ahead and post it right away.
I got a question for Lee. Does Ox, do they offer thermic analysis, where they can test the wall assembly or go through like a WUFI analysis of the wall assembly to make sure that it's okay to install if they're getting into a little higher risk assembly?
No, we don't do a WUFI type analysis. I always recommend doing that, and that usually goes back onto the designer architect scenario of who's building and who's working that. I always recommend going through a dew point analysis for all of your buildings. WUFI used to have a free version. Now they don't. You have to pay for it to get that dew point analysis in there. We don't have one either. I haven't been able to find a free one since WUFI took theirs away. But I would always recommend to an architect at least do one of them in the region that you're designing in, so you have an understanding of the amount of insulation that you're going to need outboard of the wall, just to make sure you're sealing that off, or you're getting that dew point outside of the cavity of the wall.
Good idea.
But I think your ratio, I like that ratio thing that you put out. I think if you follow that, for the most part, you're going to be able to keep that dew point outside of the wall.
Yeah, and I think that's pretty well tested. I think Building Science Corp they're pretty thorough on everything they do, so I'm sure that's pretty safe.
Yeah, so I mean, to sort of kind of to wrap that up in a nutshell, one, the more insulation you add, the more you have to get your water management details right, because you're reducing the drying potential of the wall. But if you stay above those ratios for the exterior insulation versus your cavity insulation, the higher the outside insulation number is, the safer you are for those condensation levels.
Yeah.
And of course, then keeping the inside vapor barrier more permeable. It's going to keep you safe if you're putting something less permeable on the outside.
Mhm. Again, all this is based on climate. So go back to that first slide that I showed with climate, or one of the first ones with that climate zone map. Make sure you understand where your location is, because you don't want to build the way I do in Austin, Texas. You'll have problems.
For sure. Let's see. We had someone. Oh, we had someone ask about. We had a couple of questions sort of related to fastening insulation to the exterior. Someone wanted to know if you could mention, Randy, what some of those washers were, or
Sure.
where they could even find them, perhaps.
Yeah. So this one, it's called, I actually had to look this up to make sure I had the right name. It's TrueFast Grip Lock Hurricane Washers. I found these you can get them online. I think if you key in that name, you could probably find a distributor that'll sell them. They come in a pretty big quantity. Yeah, I don't think you can buy them singly. There might be 500 or 1,000 of them in a box, which is enough to do quite a few houses. But and if you're doing a temporary, if you can get it covered up real quick, just a standard cap nail will hold it on, and as long as you get something behind it, if you're doing a rain screen, vented rain screen or whatever, that'll help hold it on. If you're working your way across the wall trying to install it at the same time, it just needs a few minutes to hang on there, and then that rain screen will make sure it doesn't go anywhere.
Yeah, I know some people are asking like about temporary fastening of rigid continuous insulation before the furring strips go on, and someone asked if you should use adhesive, but I think like usually a fastener, you really don't need a whole lot to hold one of those boards on. In fact, like what I've seen people do is just cut up a bunch of little scraps of thin plywood and throw a long screw through that as a temporary hold. And if whether you leave that in there under the reins after you put, or if you need to pull it off when you go to put the furring strips on, you just put some tape over the hole. But there's a lot of ways you can temporarily hold it on there. It doesn't really take that much for most types of insulation.
Yeah, I don't think you have to go through an adhesive. I mean, you're going to have a pretty sizable investment in the amount of adhesive that you need to make sure that you can adhere that to the side of a building. It's a lot of insulation that goes on the side of a building.
Okay. Some people are asking if you have a siding material that is not at risk of being damaged by moisture, would you forego the rain screen altogether and go right over the rigid insulation, like PVC siding? Or
I believe the code has got I can't remember if that's in the vapor barrier, where it says that if it's a material that can't be damaged by moisture, you're clear. That might be in the vapor barrier, where you don't need a vapor retarder section of the code. But yeah, I don't think if you get something if you get concrete block, it really can't get damaged. Of course, you don't want moisture moving through the block. That can happen. But it's just a matter of how do you tie your, without that WRB in certain instances, are you tying your windows in correctly? There's lots of considerations. There's lots of things to think about when you're trying to do something like that, to make sure that water management is correct.
Okay. I know you touched on it in your actual presentation. Someone was asking about some of the pest management details. In fact, someone even asked about if you've got siding open for an extended period of time. And I know this is more of a concern with things like softer foams like EPS or even with mineral wool, with birds even nesting in the siding, or woodpeckers pecking into the insulation before it's covered up. But have you had to deal with any of that kind of stuff before?
Most of the foam or insulation or WRB products, if you're using a whatever house wrap you want to use, they're all have a listed open time on them, and you want to follow the manufacturer's recommendations on that. If you're planning on siding your house 2 years down the road and you've got exterior foam insulation on there, for instance, chances are that foam's not going to be very good quality by the time you're ready to decide. So if you're doing that, if it's a long time before you can get it covered, maybe you put a something that you can pull off later on it, a cheaper version of a house wrap, for instance, to get it covered. Maybe you go with a UV rated house wrap that's designed to be open to the sunlight for long periods of time.
Just what I would recommend is just checking on what type of insulation you're using. The better the insulation, the longer it'll be able to maintain itself. For example, I had a house in Telluride, Colorado, being built at 11,000 feet. They used my product that has a tri-poly rigid facer on the outside of it. And they left it exposed for 2 winters because it took so long for them to build that. We had to go out there and do an inspection each time they started building it on it again, but it survived 2 winters with snow right up against it. So just be aware of what type of insulation you're using. Closed cell and faced insulation will definitely last longer if it's going to be in an exposed situation.
Okay. Let's see. Oh, we did have someone ask Randy if we'd be able to put your slide deck in as a download on the.
Yeah,
is that something
I can get that to you.
Send us a
Yeah.
copy of that.
Yeah.
And someone also asked, and I mentioned this earlier, but I'll reiterate that we will have a recording of this presentation at findhomeland.com/webinars. It'll take our video people a day or two to get it live there. So just check back in a couple of days. And I will, I think we're just about ready to wrap up here. Do you guys have anything to add, or did you notice any questions that I didn't highlight in the chat there? I do know, actually, before we go, Lee, a couple of people were asking about the particular products from Ox Engineered Products. Can you kind of elaborate a little bit on that combined structural sheathing and insulation product?
Yeah, just real quick, it's our Ox IS product. IS stands for insulated sheathing. If you're familiar to Zip R, or like you had mentioned before, you're talking about the product that has the OSB attached to, like as a nail base that's attached to insulation. Similar to that, it's going to be a much more cost-effective way to achieve both structural board and continuous insulation. And it's actually installed a little bit differently than what like the Zip R does. So the challenge with the Zip R product is it's actually reversed. And so you have the insulation sandwiched between the exterior sheathing and the wood stud when you're installing it, because they have that green coating as their WRB. With our product, our insulation board or our structural board is right up against the studs. And it's actually a thinner structural board, but it gives you double the structural value for shear than the Zip product does. And it's going to be a lot thinner finished board as well. So we have 3 different sizes: 1/2 inch total thickness with an R3, a 1 inch R6, and a 1.7 R10 are kind of our standard thicknesses that we have available. Built-in weather-resistant barrier, similar to what the Zip product is. We have our own taping system. You just need to flash the edges of the board, or the seam tape around the edges of the board, and then we have a flashing tape for all of the penetrations. And with that product and our tape, if you use it, we give you a 30-year system weather-resistant barrier warranty, which is the best out there available by the manufacturers.
Great, thanks. Randy, anything else you want to say in closing here?
Thanks.
Yeah, thank you for.
Yes.
I know you've got decades of experience, dealing with these sorts of topics, and we really appreciate you joining us here this evening to share some of that knowledge with us.
Yeah, this was pretty short. We've only got a little over an hour into this presentation, and there is so much information on this topic. We could have talked for a full day or more trying to cover everything. So just be aware there's a lot to this. Make sure that you understand the processes, and don't be afraid to reach out to manufacturers. both the siding, the windows, for sure the insulation manufacturers, make sure that you understand their products and they're used correctly.
Okay, great. Well, again, I want to thank you both, and I want to thank Ox for sponsoring this webinar.
Thank you.
And if anybody wants to find out more about their products and where they are available, Lee, what's the website that we want to go to?
It's pretty easy. It's it's www.ox for Ox and then EP for engineered products. So oxep.com.
Great. Thank you very much. And everybody check back soon at fineharmony.com/webinars for the presentation and any other additional information that we add there. And of course, for all of our past webinars and notifications about upcoming presentations. Thanks, guys.
Thank you.
Take care.
Thanks, everybody.